All right, 3.1, solving equations using addition and subtraction. Okay. Now, we want to talk about the word equation. Okay. We've already really talked about this before, but let's just remind ourselves, an equation is a mathematical sentence where a variable is involved. Okay? An equation is going to have a left and right side with an equal sign. Okay, it's going to have a left and right side and an equal sign. Okay, we've really already talked about that. What solving means, to solve an equation, is to come up with the solution. Let's make that better. Is to find the solution, okay, which is the value of the variable. That's what solution is. That makes the statement or sentence true. Okay, to solve it is to find the solution, the value of the variable, that makes the statement or sentence true. Okay, that's what solving is. Okay, we solve by using inverse operations. Okay, I'm not really going to give you a definition for inverse operations, but we know that the inverse operation, the inverse of addition is subtraction. The inverse of subtraction would be addition. Okay? All right, now, the other thing that we need to understand, it's a new word that is a linear equation. Okay? A linear equation has variables that are raised to the first power. Okay? In other words, x to the first, z to the first, x plus 5, x minus 6. Okay? Those are all linear type equations. Equations that, for example, x to the second plus 5 equal 10. Okay, that is not a linear equation. Okay, because its variable is not raised to the first power. Something, let's talk about this for a second. We'll eventually get to these, but not in this chapter. Not linear would be, like I said, x to the second plus 5 equal 30. X squared plus 4 under the square root sign equal 20. Okay? Those are not linear equations. Okay? Another one that a lot of times people don't think of, x plus 3 and absolute value signs equal 7. Okay, those are not linear equations. We will not be dealing with those in this chapter. Now, we will eventually. Okay, this year, in fact, we'll eventually deal with some of those types of equations. They're not necessarily real hard. It's just they're not linear. Okay, when you have a linear equation. Okay, when you have a linear equation, you're going to have exactly one solution. Okay, linear equations have exactly one solution. Okay, linear equations have exactly one solution. Okay, these others that are not linear, they're going to have multiple solutions. Okay, so just a side note there, but we need to know the two different types of equations. All right, now let's look at some examples. Now, let me show you one. This that is a linear equation. Okay, it's when it looks like this that it's not linear, when the variable and the mathematical operation are included in the absolute value signs. Okay? This equation here just means this. What is the absolute value of negative 6? 6. So that I can rewrite that equation as 6 plus y equal 5. Okay? Now, that's fairly obvious what the answer is. We take and we subtract 6 from both sides. Okay? That cancels, leaving me with y equal 5 minus 6. Okay? 5 minus 6 is 5 plus negative 6. 5 plus negative 6 is negative 1. Okay? That's what that equals, 5 minus 6. Okay, like I said this on Friday last week. I said you need to start getting to the point where in your mind you can change those subtraction problems to addition without having to actually do it on paper. You need to get to a point where you see 5 minus 10 and you automatically know that that's negative 5. Okay, we've got to start getting into that thought process without having to change it. If you have to change it, then change it, but we need to try to start getting to that process where we don't have to change it. Okay? If you're still not there yet, that's fine, understand, then do the other. Now, this process doesn't change to solve equations if we put fractions in here. Okay? It doesn't change the process. We want to do the inverse operation of addition. The inverse of addition is subtraction. So we're going to subtract 3 1/4 from both sides. So that means we're going to subtract 3 1/4 over here. Okay? On this side, on the left side, it cancels out. Because when I add 3 1/4 and then I take and subtract 3 1/4, those two cancel each other. Okay? By our properties of opposites, if I have a positive 3 1/4 and a negative 3 1/4, they cancel each other out. Okay? By the property of opposites. Yes, Matthew. What? No. If they give you your original problem in fractional form, you need to have your answer in fractional form. If they give you the original problem in decimal form, then your answer needs to be in decimal form. Okay, so whatever initial problem they give you, that's how you need to finish your answer. Okay, now, if I subtract 2 1/2 minus 3 1/4, well, I got to have common denominators, so that's 2 over 4, and that's 1 over 4, and that's done. Now, this has to be plus a negative. This is where it gets a little confusing. Okay? I have to take the absolute value of those two. Okay? Negative 3 1/4 is a larger absolute value than 2 2/4. So what it comes to is this. Okay, because I have to put my larger absolute value on top. Okay, and so now I have 1 minus 2. Can I do that? No. So I have to borrow, make that a 2. I'm going to add 4 to 1, which makes it 5 over 4. 5 over 4, now I can subtract 2/4 from 5 over 4. What is 5 minus 2? 3. So this would be 3 over 4. And its larger sign is negative, and so it would be negative 3 over 4. So, R would be equal to negative 3 over 4. That's one of the harder problems that you will have to do. Okay, let's look at another one. 19 minus the opposite of y equals 25. Okay. Now, here's where you run into a little bit of difficulty. Okay. You have to take, and realistically, we have to take and change this problem. Okay. Change that to addition. Do the opposite of that, which is positive y equal to 25. Okay, when you do that, that allows me to subtract 19 from both sides. Okay, when I subtract 19 from both sides, that gives me y is equal to what? 6. Okay. The reason that we had to do that is because of this. let's say it was just 19 minus y equal 25. Okay, well, I'm not subtracting 19. I'm subtracting y. Okay, if I redid this one, you would have that, which is really that right there. So realistically, I'm adding 19 to a negative y. Okay, well, the inverse of adding 19 would be to subtract 19 from both sides. Okay, and so you can't look at it when there's a subtraction sign involved and the variable is behind that subtraction sign. Okay, you have to think of it in these terms like we just did, either here or there. Okay, you have to think of it in subtracting definition. Change the subtraction to addition, do the opposite of the number behind it. Well, let's say it was like this. Y minus 19 equal 25. Okay, well then, yes, I am subtracting 19. So the inverse of subtracting 19 would be to add 19. See, you get up here to our original problem of 19 minus negative y equal 25, and you just go, oh, okay, well, I need to add it. Well, if you add 19 to 19, they don't cancel each other out. In other words, if I wrote this problem horizontally, 19 plus 19 minus negative y equal 25 plus 19. Because what I do to one side, I must do to the other. Well, 19 plus 19 doesn't cancel each other out. Okay? The only way I can cancel out the 19 is to have a 19 plus negative 19. That's the only way that they cancel each other out. And that's the whole point of solving. Okay? I'm trying to excuse me. I'm trying to cancel out what is on one side of the equation. Okay? I'm trying to get the variable by itself. Okay, that's what it means to solve, to find the value of the variable. Well, the only way I can find the value of the variable is to get it by itself. Okay, on one side or the other of the equal sign. Okay, so those are just some, comments and recollections for you. All right, now I want you to try this one on your own. X plus 4 minus 3 equal 6 times 5. All right, we'll finish on Thursday. Okay? Finish on Thursday. Okay? Study for test number 2 tonight. Okay? You may go.